Hello friends, this video on integers part 18 is brought to you by examfear.com. No more fear from exam. So now that we have learnt about division, let us quickly look at the division properties of integers. Now here we will not learn something very new. The same properties which were applicable for multiplication, we will check out the same properties for division. Closure property, commutative property, associative and distributive property. So before that, let's talk about division by 0, because for multiplication we saw that whenever you multiply any integer with 0, the result is 0. What about dividing an integer by 0? So any integer divided by 0 is not defined or meaningless. So it is not 0, it doesn't have any meaning basically. So we call it as not defined. So you think of any integer minus 1 divided by 0 is not defined. You talk about 122 divided by 0, that is also not defined. You talk about 0 divided by 0, that is also not defined. So anything divided by 0 is not defined. But when you talk about the other way around, for example, if you talk about 0 divided by minus 1, so in that case, that is not defined because you are dividing 0 by some other integer. So therefore, the result would be 0. When you divide 0 by 122, then the result is 0. So when 0 is divided by any integer, then the result is 0. But any integer divided by 0 is not defined. Division by 1. Now, any integer divided by 1 gives the same number. So 1 again retains the identity of that number. For example, you talk about any integer. Let's say you talk about minus 21 divided by 1 gives minus 21. You give 0 divided by 1, that gives 0. You talk about 25 divided by 1, that's also give 25, and so on. So any integer you divide it by 1, you get the same integer. Let us now talk about the closure property. So when we talk about closure property, we see that integers are not closed under division. So that is something new, or that is something different that we observe in case of division from multiplication. So let us quickly look at it. Let's say minus 3 divided by 1. What do you get? You get minus 3. 15 divided by minus 5. You get minus 3. Minus 25 divided by minus 5. You get 5. Minus 15 divided by 0, what do you get? It is going to be not defined. So this not defined is definitely not an integer, and therefore we cannot say that integers are closed under division. So they are not closed. Sometimes they give integers, sometimes they do not. Commutative property. So this here again we see that division is not commutative. Had it been commutative, in that case A divided by B should have been equal to B divided by A. But is it actually true? Let us look at some examples. Let's say minus 15 divided by 3. The answer is minus 5. Now if we change the order, that is 3 divided by minus 15. So what is the result? We get minus 1 by 5. Are they the same? They are not the same. Therefore, A divided by B is not equal to B divided by A. Let's look at some more examples. Let's say minus 16 divided by minus 2. The result is 8. Now when you change the order, that is minus 2 divided by minus 16, it is 1 by 8. So again, the results are not the same. Let's look at yet another example. Say 1 divided by 0 is not defined. But when you look at 0 divided by 1, that is 0. So this is again not the same. So time and again it is being proved that commutative property doesn't hold true for division of integers. That is, A divided by B is not equal to B divided by A. Let's look at the third property, that is the associative property. Now, this property also is not true for division of integers. Now, had this been true, then A divided by B divided by C should have been equal to A divided by B divided by C. Now, let's see if this is actually true or not. So, for that again, we take an example. Let's say 15 divided by minus 3 divided by minus 1. So, this is our left hand side. and let's say the right hand side is 15 divided by minus 3, this divided by minus 1. So here the value is 15 divided by 3, which is equal to 5. And in this case, the value is minus 5 divided by minus 1, which is also equal to 5. So here, yes, we see that both are equal. Now, but we cannot reach to a conclusion just with one example. Let's take some other example, because sometimes it might happen that just by a matter of chance, the left hand side and the right hand side are equal. So we will take more examples. 18 divided by minus 6 divided by 2. This is 18 divided by minus 3. And this is equal to minus 6. Now let's solve the right hand side for this, which is 18 divided by minus 6 and this whole divided by 2. So this is minus 3 divided by 2, which is equal to minus 3 by 2. So do you think both are equal? They are not. Therefore, A divided by B divided by C is not equal to A divided by B divided by C. So this is not equal. Now if you want, you can take more examples and you will see that there might be certain cases where by coincidence this holds true, but it is not universally true for all the cases. Now the last property, that is distributive property, and again distributive property is also not true for division. Now had this been true, then A divided by B plus C should have been equal to A divided by B plus A divided by C. So we will take an example to illustrate or to verify this. Let's say 15 divided by 3 plus minus 2. So this is our left hand side, and what is our right hand side? 15 divided by 3 plus 15 divided by minus 2. So this is equal to 15 divided by 1, which gives 15. Now let us solve this side. This is 5 plus 15 divided by minus 2. So we get, what do we get? You take the LCM as 2, and this is 10 minus 15, which is equal to minus 5 by 2. So do you think they are equal? They are definitely not, and therefore distributive property does not hold true for division of integers.
Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.